Welcome to Software Snack Bites. I'm your host, Shomik of Bold Start Ventures, where we partner with Dev First and SaaS founders from the first line of code. Today, we're excited to have Matt Butcher and Steve Manuel on the show. Matt is the co-founder and CEO of Fermyon, and Steve is the co-founder and CEO of Dylibso. For those who don't know, both these companies are advancing the usability of WebAssembly. In this show, we'll cover the basics of WebAssembly, why there's so much excitement in the cloud computing space about the technology now, and what the future holds. So with that, let's first start off with Matt. Can you describe what it is that Fermyon does, and also give some background on why you started the company and what got you excited to build around Wasm versus other areas?
Yeah, absolutely. Fermyon, we started around November of 2021. So we just kind of passed our 1-year anniversary a few months back. And now we're like heading toward, 18 months. It's wild. Things have gone so fast. We all came out of Microsoft. And while we were there at Microsoft, we were deeply engaged in the Kubernetes ecosystem and in the container ecosystem. But along the way, we started to find a couple of places where we saw there was an innovation necessary for us to be able to kind of make that next leap in what we wanted to do in the cloud. And really, like for us, that kind of key focal point was we watched the rise of serverless functions. And people were very enthusiastic about the model and very enthusiastic about what they could do with them. But the whole architecture was sort of built on a set of primitives that didn't quite match the runtime profile people were after. In other words, we were building the coolest, greatest, newest technology on top of a 10 or 15-year-old virtual machine technology. And we started hunting for a different kind of cloud computing engine that would be able to run these kinds of workloads faster, more reliably, ideally with smaller binary sizes and nearly instant cold start times. And that's what ended up bringing us toward WebAssembly, which we'll be talking about quite a bit today. Now, fun fact here, Steve and I do not live too far away from each other. So during this whole time, while I'm thinking about what we want to do at Fermyon, Steve and I would get together at the local coffee shop about a mile and some away from the house, and I'd run ideas by him and he'd give me advice. So we've known each other for quite a while. I don't think Steve even knew at that time that he too was going to dive into the deep end and do this thing.
That's right. Colorado seems to be the headquarters of WebAssembly companies. So.
That's what I was going to say. There's something in the water there. I don't know what you guys are drinking, but something in the WebAssembly waters. Yeah,
something in the beer.
And Matt, one thing is just describing what Fermyon does as well, just so everyone knows.
Fermyon, we are focused on building the developer tools and a cloud platform for making it super easy to go from, blinking cursor to a deployed serverless WebAssembly-based application in, we're saying now, 66 seconds or less. A year ago, it was 2 minutes. Now we're down to 66 seconds.
I love it. That's getting faster and faster.
That's right. Yeah.
And by the way, you were the reason that Steve and I met, so thank you for that.
Sure.
and appreciate it. But Steve, let's have you do the same. So talk about Dylibso and also motivation to start building specifically in WebAssembly versus all the other things you could have built around.
Dylibso, first and foremost, is foundationally focused on helping build developer tools to make it easy to take WebAssembly to production, and then once it's there, to keep it in production. So think about things like observability and monitoring and debugging. How do you actually get the same level of support for your development and your ops team to run WebAssembly in production and feel confident in its existence in your prod stack? And the motivation for starting the company started really, I was at Cloudflare working on the Workers product and responsible for bringing kind of new language support. And so I added Rust as kind of a first-class citizen in addition to JavaScript. And in order to do that, you had to actually, compile your Rust code to WebAssembly and interact with the JavaScript APIs that the Cloudflare platform provides. It was, to say the least, a bit of a tricky project. And most of it was due to the lack of, developer tooling and debugging support and analytics around really what is happening in your WebAssembly code as it's executing, how it's interacting with its environment, or why is it failing to interact with that environment. That kind of planted the seeds. And then I spent some time after Cloudflare working on compilers and really started to understand some more of the lower level requirements for building developer tools that operate at the instruction level in a binary file, and thought that there's a lot that we can do to make the experience a lot better for developers. And, these are kind of difficult problems to solve, and felt that a company was probably the best vehicle to actually accomplish those goals.
That makes complete sense. Well, one of the things is both of you, I consider, are just super talented engineers and people in the ecosystem. And so you're clearly seeing stuff about WebAssembly that gets you excited. And I think it's something that I'd like to help the audience understand a bit more. So people are asking, what the heck is WebAssembly, right? Someone's looking up online, they'll probably see things like It's a binary instruction format. I literally, by the way, just did this just to kind of, because I was curious. It's a compilation target. It's machine readable code, right? And so I think we'd all like to make it a bit more human readable, like a little JavaScript joke there for everyone. But, I guess maybe just talk about what is WebAssembly. So Matt, why don't you have us kick it off here?
I'm glad you let me kick off Kurt first, because I can do like the high level part, and then Steve can jump in and go as low level as you want to go on this question. To me, when I think about WebAssembly in terms of like the history of what we've built, this grand edifice of computing, it's easiest to connect it with sort of what Java was after when Java got started, and what .NET was after when .NET picked up a few years later. In both of those cases, those communities, those ecosystems were creating a language that could compile to a neutral format that could execute on all different kinds of devices. Java, few people know that Java's original design intent was actually embedded systems. They were looking for a way to do embedded system. Now, it turns out they were early enough that the performance problem became sort of untenable, and Java sort of exploded outward into all these different environments. WebAssembly 2, started as this idea that we could have a sort of bytecode-y format that executed inside of a web browser. And essentially, this is an assistive technology for JavaScript originally, right? You could write some high, like what Figma did, write some high-performance C++ code, compile it to this neutral format, run it inside the web browser, and use JavaScript to connect the two. What the surprising outcome of this has been is that WebAssembly as a technology can be plucked up out of the browser and dropped into other cases. Again, sort of just like the way Java did it. And I guess the only thing I would add to this before I turn it over to Steve, who will give you a much better answer than I did, is that the feature of WebAssembly that was really compelling to us at Fermyon was the security sandbox model. Now, Java and .NET, I'm comparing them to those things. Java and .NET were really designed so that a developer could write in their language of choice and run on a different operating system, but still have access to all the operating system features. So by default, the security disposition was to allow the developer to access system resources. By default, WebAssembly takes the opposite security posture. We do not allow the user free access to system resources. Again, thinking about the browser, you don't want to load something in the browser that's going to be able to do dastardly things to your operating system. And so it was really designed with sort of the inverse model, and then using sort of capabilities models in WASI and some of the new WebAssembly specifications that are coming out. We carefully and securely allow developers to access facilities that feel familiar to them, even if they're not necessarily ideally backed by the operating system itself. So, for example, we allow the developer to open a thing that feels like a file and looks like a file from the perspective of the guest code. It may or may not be backed by the actual file system, but all of that is an implementation detail as far as both the developer and the host runtime are considering it.
Yeah, great answer. And I can't really add a tremendous amount to that. But I would say, just to kind of go a little bit deeper on, maybe illuminating the audience as to what like the compile target aspect of WebAssembly means, is that, WebAssembly describes an instruction set for which higher level languages can compile down to. Higher level language is anything from C and above, basically, including Rust and Go and Zig and all these other fantastic languages that are getting improving support to reach WebAssembly. And once it's in this compile target, the unique thing about WebAssembly was that it was designed for the browser, so the code can run inside every modern mainstream browser today. We've also seen now this proliferation of runtimes outside of the browser, and organizations putting a tremendous amount of work and effort into making these runtimes incredibly quick and performant. And WebAssembly's instruction set is more like a reduced instruction set that doesn't have a whole bunch of complex system calls and unstructured code flow. And so you're able to concisely and compactly compile code into a format that can be quickly executed in these runtimes. And a benefit is that the size of the code tends to be significantly smaller as the execution unit, because it's not bringing in a bunch of system resources and additional libraries that are provided by the host operating system. Instead, the runtime itself actually has those capabilities and just executes the WebAssembly code to just do the job that the programmer has instructed the code to do, and not worry about how to actually interact with the host environment or network or do anything like that. These are capabilities, as Matt mentioned, provided by the runtime to the code. And so all that stuff is externalized, making the code much more simple and kind of easy to execute.
One question that I just have, and either one of you can take this, but is there an easier way for someone to get the speed of WebAssembly? And so what I mean by that is, if you're working on the back end only, C or C++ or whatever, you're as close to machine code as possible, right? So that's pretty freaking fast, right? But coding in those languages, not easy, right? Pretty hard for people to know them, figure it out. So is there any other technology in your guys' mind that can replicate the speed and ease of use of WebAssembly?
When you combine that speed and ease of use, there's a philosophy joke about this, right? That, when you ask the question, what's the smallest, fiercest animal, you end up having to say, well, which is more important to you, smallness or fierceness? For us, WebAssembly hit the ideal, right? There might be, if you're willing to tune the trade-offs a little bit differently, there could be another one. But for us, it hit the ideal. We could get really, really fast startup times, really, really decent performance. And on top of that, we get this excellent security model. I know Steve hinted a lot about this in his definition and didn't quite say it. It has an observability advantage that very few other formats do as well. And that's huge when you're doing cloud. I mean, I know when we were doing container observability, it bubbles all the way down to like telling every developer, please instrument your code in this very, very particular way for our very, very particular observability stack so we can figure out what's breaking when something goes wrong. WebAssembly has all of these great trade-offs that really make it feel like a natural fit. And we just, even back in the days when my team was at Microsoft, we looked and looked and looked around the landscape for something else that seemed to check all of the checkboxes. And WebAssembly was really the only one that bubbled to the top. And we feel great about the fact that its performance is great, but also about the fact that we get all of these other things, the security, observability, and so on through the stack. There's one more thing I'll quickly mention here, which is that language support plays a really big role in what made WebAssembly attractive for us. I think what makes it attractive to Steve. When you can compile Rust into WebAssembly and C and run Python and JavaScript and we're seeing language after language adding support. That is so big of a boon in its own right that I think even if we were to see other high performance system languages, and Rust is actually a great candidate for that, even if we were to see them begin to gain huge traction, the fact that we get all these other benefits of WebAssembly and can compile those languages into WebAssembly makes it kind of the right target for the kinds of things that we are interested in building.
Got it. Steve, let's riff off of what Matt just said, though. So the multiple languages can get compiled, right? That sounds amazing. That's like what we've all been dreaming of, right? So why isn't WebAssembly everywhere? Like, why is every single developer not using this, given all the benefits that we just talked about?
Like I mentioned before, where WebAssembly was originally designed to target the browser and take high-level languages compiled to WebAssembly and execute it in this browser-based runtime, we're starting to now see a expansion of runtimes available outside of the browser, and it's just taking a normal amount of time, I think, for a technology adoption curve for developers to see these opportunities to run WebAssembly elsewhere. And once the benefits are truly understood of why WebAssembly makes for a fantastic execution format and runtime environment, it won't take long for it to catch up and surpass many, many other modes of deployment and code execution. So I think really it's about, okay, we've got, the Bytecode Alliance working on Wasm time and other fantastic runtimes like Whammer, targeting a bunch of different kinds of architectures and sizes of computers, all the way down to the microprocessor and all the way up to like the server rack you otherwise might ship containers to. So I think it really is just a matter of the ability to run WebAssembly in more places outside of the web, and largely thanks to companies like Matt's Fermyon, who are pioneering the iteration of how to get WebAssembly out of the browser and elsewhere in your stack. So I think that we'll see a lot more adoption once people just kind of understand how they can use it and why it's beneficial.
Yep. Matt, is there anybody that, and this is going to be maybe a little bit spicy, but is there anyone that shouldn't use WebAssembly, right? Like who, if you were talking to someone who would not be a good fit from everything we've described, right? Who would not be a good fit to use this?
There are some very clear cases. It pains me to say this, right? I would like WebAssembly to solve all the world's problems, but it's not there. It's not there yet, at least. And many of these things that I'm about to say are things that will improve over time. But WebAssembly is still, all things considered, a young technology. And again, as Steve just articulated so clearly, like we're just learning about a whole bunch of new cases in which we can apply WebAssembly. But it doesn't have multi-threading yet. The memory management system is still sort of in flight. We're working on things like certain aspects of network access and things like that. All of those would make building a database very, very hard in WebAssembly, right? If you're going to build an RDBMS, WebAssembly is not for you, right? Stick to a lower level language that's more powerful, can do low level IO very efficiently, can do, concurrency very effectively. Those are the things that are not WebAssembly's forte. And buried in there are things like IO. IO is always going to be a little bit slower than native if you have to go through a security layer, right? A non-porous security layer, which is what we do, right? And until the concurrency story is sorted out in WebAssembly as a whole, it's not going to be able to do the kinds of things you need to do when you're writing large, what I would call monolithic. I know that term's sort of loaded, but when you're talking about a big thing that's going to run for a long time and handle tens, hundreds of thousands, millions of requests, you don't want to write that thing in WebAssembly yet. Right? If you're writing small pieces of code that are very specific to a particular task, plugins, UDFs in databases, serverless applications like Fermyon does, those are excellent cases for WebAssembly, and you really kind of squeeze out all the benefits of WebAssembly in those cases.
I feel like the Jamstack community is celebrating hearing that because, they're all behind like the resurgence of the monolith, and they're like, like no WebAssembly in the monolith. But no, I think that makes a ton of sense. Okay, so we talked about who shouldn't use it, but some of the use cases, obviously are there. I think, Steve, let's start you off here, but I think talk about 1 to 2 companies that are using WebAssembly for whatever use case you'd like to talk about. It could be client side, it could be server side, or just like a really cool end product that it helps deliver. But basically what we're trying to do is give a flavor to folks about how it's actually being used in production today to help end users.
Sure. I think one of my favorite use cases that's actually like a large scale implementation of WebAssembly is Shopify's Functions product. They've forever had, a pretty deep integration into the guts of the Shopify platform for developers to be able to slightly modify and turn some knobs and levers to get Shopify to do a little bit more than it was originally designed to do. But there was always some friction. There was always some limitation as to really what could be exposed. How many forms can we add and checkboxes can we add to let somebody configure their site or their shop in a certain way. And over time, more and more merchants joining the platform, having different use cases and different needs from their customers. Products, had much more variety, and they're building out more substantial, significant kind of e-commerce technology. And in order to satisfy all these needs from these different variety of merchants, they thought, I think we should probably give them, very deep control and access to the inner working of the platform in a safe way. So they shouldn't be able to read and write directly to our database or have access to our native, functionality. But can we add this shim layer between, the user space and the Shopify internal space to give merchants and developers on the platform more access to customization? And so they've recently been putting a lot of effort into this Functions product, which lets developers ship WebAssembly code that implements a interface that can interact with the Shopify environment, so that in the case of a user adding an item to their cart, a function can run on Shopify side and understand what's in the cart, understand the context of the user, give someone the ability to write code to determine, based on the logic represented in this WebAssembly code, apply this particular discount or add another product to the cart for free, or whatever the merchant wants to do. They have kind of arbitrary abilities to customize that shopper experience. And they're doing it at a significant scale. It's really, really impressive to see them do this. I think on the other side, so that's kind of the more server side project. There's also really an interesting use case, which doesn't get as much attention, I think, that it deserves. But I think it was Disney Plus uses WebAssembly to ship thousands of different front-end clients running on the TVs and the phones, the tablets, and all that kind of stuff. And they're using WebAssembly for at least the majority or some of their componentry to display and interact with the server, so they can have a consistent development experience and ship to all these different endpoints without having to rewrite code in a variety of different, front-end frameworks to support all these different client-side applications.
I'm told that both Amazon Prime and BBC also use WebAssembly for the same thing now. So you have 3 of the biggest streaming providers saying, this is a way to get a big job done, support thousands of SKUs as far as hardware goes, and do it really effectively.
What's cool, though, is that what you would think is you hear Shopify, right? And you hear Amazon, you're like, okay, tech forward, makes sense they're doing this, right? Matt, you mentioned Figma before, right? Of course, they're all playing around with this, doing that. But then like Disney has been around for a very long time, right? And so the fact that they're doing stuff here, the fact that the BBC, right, is exploring stuff here is pretty impressive. But Matt, maybe, can you give what companies you're excited about that are doing?
Yeah, I can give sort of an overview of the kind of three workloads in order of how surprised we were to see these emerge. We targeted originally, we were out saying, the crowd we would love to win over is, small development teams that are trying to write web application backends, that are trying to write microservices in a far more efficient way. And when we launched Fermyon Cloud last October, that was exactly the first group we saw land, was a lot of developers who were just trying to build these kind of faster, more scalable, and also cheaper microservices and web application backends. The next most surprising thing for us was that we also started to see a lot of people use these to build Slack bots and to build other kinds of things that we kind of jokingly call bursty workloads, where it might sit silent for a long time and then all of a sudden get a whole bunch of requests and then sit silent for a while. And WebAssembly, because you can scale down to 0 and run nothing when there are no requests coming in and then sort of instantly scale up to tens of thousands, ends up being a really good model for it. But Slack bots, and now ChatGPT, of course, yeah, we've been playing around with that in-house too. All of these things where it's like, for a little while, somebody's going to do a whole lot of computing and then they're going to go away. You need to free up those resources. The most surprising for us on this, 1, 2, 3, Microsoft rolled out support for WebAssembly late last year inside of AKS, and they support Spin and they support Slight and basically a couple of different runtime models where you can build and execute WebAssembly. What they are saying and what they tell us they're saying is that there are a wide variety of cases where people can't quite get the cross-platform, cross-architecture they need in Kubernetes when they're running on containers that they can get out of WebAssembly. I do not know who is doing all the work, but there are a number of places doing a lot of research to try and say, can they extend Kubernetes out toward the edge? If the edge nodes can run WebAssembly and they can sort of parcel out WebAssembly workloads to these edge nodes. So that one was a surprise to us. Admittedly, if you had asked me a year ago what the story was with Kubernetes and WebAssembly, I would have said, there is none, right? Kubernetes it's not going to make the leap. So for me to see now, not only that it has conceptually made the leap, but that that Microsoft has customers are putting into production that are using these technologies, that's quite exciting. I am pleased to be wrong in this case.
I'm excited because that's going to lead to a question that I had in mind, which I think we'll have some good hot takes to share. But actually, one thing I'm curious about, you mentioned that the Slack bots. Right now, I guess WebAssembly is still getting adopted, right? The tooling, which you guys are both working on and a number of other people are working on to enable WebAssembly generally just to be easier to use, is still in the process of happening. So for something like building a Slack bot, I guess, would you recommend people to, hey, go and use WebAssembly right now because the benefits of it to ship something as simple as a Slack bot will be actually great because of those fast startup times and things like that? Or is it just like, hey, listen, you're trying to ship a Slack bot, it's not the hardest thing in the world to build, right? So you can just kind of get that spinning up. Like, how do you think about that friction to use WebAssembly and someone saying, hey, I'm going to use WebAssembly to build the Slack bot, and the VP of engineering being like, dude, just ship the Slack bot. Like, what are you doing, right?
One of our passions from Fermyon's inception, and also one of Steve's, right, and one of Dylibso's, is we want to make tools that simplify the developer experience so much and simplify the day two operations so much that's not even a question, right? They should be able to do this as fast or faster than they could. In many of these cases, faster than they could with their native tool chain, just because the tooling is very straightforward if we build it right. And the runtime profile of WebAssembly is such that if you're writing a standard Slack bot, your typical way of doing this is, well, path A, I'm going to run a server all the time. And if I deploy it into Kubernetes, I'm going to be running 3 to 5 instances of that server all the time. And it's going to be sucking up that compute workload all the time, even if it's only answering 4 questions in Slack a day, right? Option B, I put it on something like Amazon Lambda, where, yeah, it's not running all the time. But as soon as the question comes in, I have to wait while the Lambda cold starts. And that might be 500 milliseconds, might be a second and a half. I don't know, right? And so we said, okay, well, there's this big opportunity here to build a better serverless underpinning that can start up nearly instantly. Ours is starting up in under a millisecond from cold start to when we're executing the first user instruction. And stuff like that makes it trivial to say, okay, yeah, I'm just going to write a serverless function that answers Slack things. And it's easy to write in the languages that I want to write in, whether it's, Go or .NET or Python or Rust, right? And then from there, we should be able to tell a really compelling story that says, no, it's easier to develop, it's easier to operate, and it's going to be a lot cheaper because you're not running 5 servers all the time. You're just scaling up when the load comes in, shutting down the rest of the time.
There's one more thing I'd like to add, if you don't mind, that unless you're using a very capable platform like Fermyon that has the nice HTTP, SDK, and libraries to handle requests, and then whatever other code in your language of choice you want to run to like power the Slack bot or the Discord bot. Many other platforms don't have those well thought out libraries that are designed by experts in those languages. So you might be stuck writing JavaScript on like a worker or something like that. And you can, with WebAssembly, the benefit is that like let the host environment, maybe it is a JavaScript runtime, handle the request and do the interop with the target platform that's sending you the webhook. But you can now integrate with WebAssembly code that's been compiled from any language that you choose. So say you have a Slack bot that takes a sequence of images from Slack and converts them into an animated GIF. Well, like you could compile FFmpeg and from C to WebAssembly, run that in your JavaScript app and pass those images as parameters. And all of a sudden, you as the JavaScript developer don't have to touch the C code and write a web server in C, which most people won't do, and run that code in your Slack bot. But instead, use the nice libraries that like Discord or Slack already make with first-class support for building these kinds of bots, and then sprinkle some WebAssembly in where it makes sense. And so I think that ability of taking code from another language and plopping it in as WebAssembly into whatever environment that can execute Wasm makes it for a very interesting use case for sure.
I think that this is one of the most exciting things about the future of WebAssembly, what you just said. If we were to start enumerating here every single implementation of a YAML parser in all the different languages, we'd run out of fingers and toes between the three of us very, very quickly and then be counting for another couple of hours, right? And you think about all the wasted developer time and all the silly little incompatibilities that we have to deal with. And the vision Steve just dropped there, right, is, well, no. I mean, you pick the best one, regardless of its origin language, and you get many of the benefits of its original. Like if you write it in C or Rust or something like that, you're going to get the high performance benefits of a language that works that way. And you link it up with your JavaScript or your Python or whatever. That's a story that's unfolding right now before our eyes, is like the Bytecode Alliance continues working on the component model that'll make it really easy to be able to import libraries regardless of language. So yeah, the portrait that Steve is painting is not just super compelling, but is well on its way toward becoming reality across the WebAssembly ecosystem.
Yeah, and one thing that, Matt, you mentioned was the cold starts with Lambdas and that being a problem. I'm curious, though, like Firecracker VMs seem to be reducing that, right? Or I'm not up to date on it, but it seemed like the announcement was pretty cool about like how it was fairly fast and stuff like that. Do you at all see that being like, hey, the startup speed, the execution speed of WebAssembly may not be as exciting then if you have these, magical Firecracker VMs starting up things really quickly?
I mean, let's look at this in the course of how things are going to unfold on time. We're currently much faster. If we put pressure on Lambda to speed up, it's a win for everybody. But the stuff that Steve is talking about, that's the stuff that's really going to begin to set WebAssembly apart from any other technology out there. So if today's story is we can get things done faster and we can get things done cheaper, that's a great story for today. But tomorrow's story is going to be we can build things in a far more efficient way. We can build sort of aggregate applications pulling in the best pieces from the best languages and then be able to instrument them incredibly well and understand what's going on in our code and where the inefficiencies are. We're going to blow away anything that's been done before in this landscape. And that's what's really exciting about the future story. So I just want to stay ahead of Lambda for maybe like 6 or 8 more months. And then if they catch up, it won't matter because all these other things will be real and will change the way that we talk about writing really robust distributed cloud applications.
Yeah. And by the way, it's pretty cool that a startup is faster than Lambda, right? Like there's a lot of people working on Lambda, just putting that out there. But so we kind of already talked about it a bit, but I really want to dive in here. So, there's the now, let's call it infamous tweet from Solomon, the previous co-founder of Docker, who you guys know what I'm talking about. But
I haven't seen this one.
Oh, never. Haven't heard it at all.
but the tweet for listeners is basically along the lines of, again, the co-founder of Docker saying, hey, I basically wouldn't have invented containers if I had had WebAssembly, right? And so that's kind of a nuclear bomb explosion in this ecosystem, right? That is freaking crazy for somebody to say. And then meanwhile, though, Kelsey Hightower actually had a great tweet. I forget when. I'll put these all in the show notes. But basically talking about like, hey, listen, like kind of not exactly the same thing, right? And so let's parse this nuance. Let's have a discussion around it. Let's help people understand. So first, maybe, Steve, why don't you kick us off? But talk about the container versus WebAssembly aspect. And then there's other questions that I'll position against. But first, let's start with containers versus WebAssembly.
Sure. First, like maybe we could level set and say like what Docker did really well to take containers as a technology that sits at the operating system level, and each operating system has their own effective flavor of containers, which is really about securing and isolating processes on an operating system, a host environment, and kind of combining and abstracting away some of the operating system specific details into really what came down to it was like the Docker file. How do you actually construct the container in such a way that it can be then rebuilt and isolated on each of these different operating systems, so long as you use a kind of Docker compliant runtime to execute that container itself. And what they're doing, right, is trying to abstract away from you the underlying requirements of communicating through software to the hardware and actually running the code on a CPU, either through a virtualization layer or natively. And in the case of Docker, right, it's virtualized on top of the CPU. And I think what Solomon is saying in this tweet is that, like, if there was a pre-existing abstraction away from, the virtualization of a CPU, there wouldn't have needed to be a large effort to create this other abstraction that Docker created on top of container technology, which had existed prior to Docker kind of mainstreaming it. And the benefit that WebAssembly brings that Docker does not necessarily is really about the size and isolation. By default, the WebAssembly module itself has all of the requirements it needs for the code to run, so long as the runtime provides the things that the module expects it to. And that is very similar to where a Docker container can run, so long as the runtime itself provides the abstraction to the host operating system that the container expects it to. The WebAssembly module just happens to be orders of magnitude, in many cases, smaller, more compact than the container itself. And therefore, you can deploy many, many multiples of these modules across the same amount of hardware that you can a Docker container, and have the same promise of isolation and security that the container technology has provided and done a really, really good job making popular and enabling all these fantastic deployment models and orchestration systems like Kubernetes.
And nobody ever quotes the tweet that Solomon sent right after he sent that first one, where he's like, whoa, wait a minute, before I'm going to walk myself back just a little. I see a future where containers and WebAssembly work well together. But I think he really wanted to point out pretty much what Steve did. That I always think in terms of cloud computing, right? So for me, it's sort of like, what are the kinds of cloud computing we need? And Docker fills a niche, right? Virtual machines came out first. They're supremely good at isolation. The image sizes are gigantic. The startup time is very slow, but you can run just about anything on them. They're the workhorse of the cloud. Docker comes along and provides something that's considerably slimmer and makes it really easy to take an existing application and package it up along with all of its operating resources and ship it out somewhere and execute it there. And so it's sort of like a middleweight class of computing. And then I think WebAssembly, the way I think about what Steve just said is WebAssembly is kind of the lightweight version, right? You're really just dealing with the executable you care about. You're getting a good isolation there at the executable layer. But again, going back to your earlier question, you can see when you parse things out that way, well, certain things are not going to work as well in the WebAssembly model as they do in the Docker container model. You can easily take, Postgres or something like that, package it up in a container and run it. It's a lot harder if you want to try and compile Postgres into WebAssembly. I'm sure somebody's done it at this point, but I'm sure if they've done it, it's slow and it's kind of cumbersome to compile and operate because you're not really playing to the strengths of the runtime.
I don't know if maybe Snaplet and Supabase did do that with the Postgres WebAssembly thing. I don't know. Like, Steve, is that what they did? You would know better.
More or less, yeah. I was able to run Postgres in the browser and connect to a remote instance in Supabase, I think.
I love it. It's
really cool. I didn't know about that. That's really cool.
I'll send it to you after. Because I was literally just thinking about it. I was like, wait a second. I think actually that's what Peter literally did. But we talked about containers, and actually maybe one other thing is like, it does sound like containers and WebAssembly still can work together, right? So I'd be curious on thoughts on that. But also, Matt, let's start off with you here. Kubernetes versus
no, Steve can answer this.
So you get to kick this hot one off, right? Because I mean, for everyone listening, Fermyon kind of works with Nomad, which is from HashiCorp under the hood, right? So does not use Kubernetes, and you've talked a lot about, you've written articles about why that's the case. So talk about like, is WebAssembly going to completely disrupt the need for Kubernetes?
I don't want to answer this question. Yeah. So for background, I worked in the Kubernetes sphere for a long time. I made contributions like writing Helm and the Illustrated Children's Guide to Kubernetes. I mean, you judge me as you may for those things. And for a long time, I was very, very optimistic about Kubernetes as really the right way to do distributed computing moving forward. And again, we started to hit some limitations with what we could do with Kubernetes, even when the team that is now Fermyon was working as part of Deis Labs at Microsoft. And a big part of that was, it is hard to get Kubernetes to flex and run anything other than a container. And that means you're really kind of locked into the restrictions of containers. And that was what led us, when we started Fermyon, to just leave Kubernetes behind, pivot over, and really invest time in Nomad, which is HashiCorp scheduler, as Shomik just said, and is very versatile and easy to extend. And I think after building Crustlet, which my team took us 6 to 8 months to get to the point where it could run WebAssembly the way we wanted in Kubernetes, we spent a weekend on Nomad and had it up and running far more efficiently than Kubernetes. So we were looking at that and saying, yes, there is a good use case here for moving beyond Kubernetes. Now, as I said, I might have to eat my words on this because we are starting to see a lot of very interesting work to be able to execute WebAssembly in Kubernetes. I still think this is me, walking back my thing and then maybe not walking it back and being a little skeptical, but I still think there's probably quite a bit more that needs to be figured out to see if Kubernetes is really going to be the right first-class environment to run WebAssembly, but at least we know that it is the kind of thing where we can have a reasonably good WebAssembly runtime inside of Kubernetes running alongside containers there. My money is still on Nomad. I love Nomad.
I want to make just one quick differentiation too. Like, I totally agree with what Matt's saying, but a lot of that is when you're considering WebAssembly versus containers as the absolute unit of compilation. It is like the entire app is in WebAssembly or the entire app is in the container. And an interop story is really also about where WebAssembly can be integrated into the application that is packaged as a container. And the container application can run WebAssembly code. And again, bring this kind of story to life about maybe I can take some of that C code from an old library, compile it to WebAssembly, and run it inside my Python server that is packaged inside of a container. And so there's a place for WebAssembly, whether you're packaging an entire app as Wasm or packaging an entire app as container, for them to live together, where this is really, I think, impressive interop story that's maybe not told quite as much, because we're often thinking about, okay, I have an app, how do I package the app and deploy the app? But really, there's also an element of WebAssembly that says, well, how can I also integrate into existing programs? I can't, not plug one of our other projects called Xdism. Our team has just done such an amazing job making this plugin system that makes it really easy to take WebAssembly code compiled from practically any language that reaches Wasm into now 16 different programming languages as a host environment, and bring that Wasm code into your application and execute it. And you can still package that app up as a container if you wanted to. But I think that there's just one little bit of nuance there to the story about it's not necessarily just a Wasm application versus a container application. The two can coincide together in other ways as well.
Yeah, I think if I can riff on that one more, I think when I think about the different ways we can apply WebAssembly, we started with the browser as the core use case, but I think there are 3 other good ones. We talked about IoT a little bit when we talked about Disney Plus and Amazon Prime and BBC. I'm like all in on cloud. You might have noticed cloud is very much my focus. And I think it was actually Steve who is the person who said to me at one point, I think WebAssembly may be the last plugin architecture we ever need to know. And I quote that all the time. So thank you, Steve. But that's the case. I think you just articulated really clearly, right? That you can make this jump from having an application that does all the things inside the app to an application that has extension points. And Xdism is a great example of how easy it should be to extend an application to provide a plugin architecture and extension mechanism for developers.
One question on that in general. So I think when normally I talk about WebAssembly being interoperable, I'm talking about use whatever language you want, right? And then compile it to WebAssembly. But what we just talked about was it could be used with containers. It could be used with Nomad as the orchestrator. It could be used still, it seems like, Matt, with Kubernetes as the orchestrator, right? So let's say it's the CTO of Coca-Cola that's listening to this right now, right? And he's sitting there and saying, okay, well, listen, within Coca-Cola, I got so many random systems running here, like I don't even know what to do, right? And so now you're telling me, okay, this thing is great. It's the best thing since sliced bread, but I need to make it work within my legacy infrastructure, and I can't have stuff break when I go and do that. So either one of you pick it up, but like, how do you think about the interoperability from that component? Does somebody need to then change over their architecture to be like, no, we're going to completely use this other random thing?
I'll take it because I actually like to plug what Fermyon does really well and some of these other kind of cloud platforms. So if it doesn't come from Matt, it comes from me. It's maybe a little bit more altruistic. So in that case, like if I'm trying to move some legacy system or maybe try to like modernize a little bit something that runs on-prem, or trying to get to the cloud, or trying to just diversify some of maybe our compute infrastructure for cost reasons or redundancy, WebAssembly plays a really interesting role where, because WebAssembly itself, and this is going kind of deep into the weeds, is architecture independent, meaning the instruction set knows nothing about the actual compute, the CPU on which the code eventually runs, that WebAssembly is a great candidate to spread compute across as many different endpoints or compute platforms as you possibly can. You could run something on-prem. You could use your old code running on-prem, never change it, maybe rip one of your apps out, compile that to WebAssembly and run it on a cloud like Fermyon. You could run containerized versions of that app and extract bits and pieces and run in like a AWS or an Azure. And so being able to extract and pull out some of the capabilities or functionality of your legacy software and deploy it piecewise in places where it makes the most sense is, I think, a very interesting characteristic of WebAssembly. And I'm hoping to see at some point a platform that orchestrates Wasm across the cloud, the edge, the browser, et cetera, where there is a consistent compute model for WebAssembly, architecture independent. So it runs on an x86 rack in Azure. It runs in a MIPS device at a gateway in some factory, and the exact same code runs on the factory worker's laptop in the factory floor. And there's an orchestrator that knows how to say, deliver the right WebAssembly to the right unit of compute when it makes sense based on the demands of that computation. And I think WebAssembly is probably the only platform that provides that kind of consistency across all these different modes of operation. And it's only a matter of time until we see that actually happen, in my opinion.
Yeah. And that's one of the things that has always kind of frustrated me about when I realized the fault in my thinking about distributed computing. It got to the point where it's almost a pet peeve now, right? Even though I was just as much hoodwinked by this, the idea that distributed computing is something that happens in a cluster in the data center. That was the premise of Kubernetes. And it was the story that really got us from looking at distributed computing as an academic exercise into looking at it as something that we could really build. But the vision that Steve just articulated, we have to get beyond the data center in order to do that, right? We have to start looking at distributed computing as a holistic problem that can span compute devices from, the watch I'm wearing to the giant data center that's in a dome under the ocean, right? To kind of even tie this all the way back to Shomik's original question, the microservice architecture may be the thing that is going to help us make these transitions and not make it painful each time, because we started learning about 7 or 8 years ago, okay, we'll break everything down to small little units. And yeah, we're going to run all the units in the same tenancy in the same data center, but if we break them down into little units, they're going to be easier for development teams to manage. Well, now that same pattern is freeing us up to say, in existing architectures, right? In legacy architectures, we have units that we can start to replace. And we can say, okay, well, we're just going to retool this one chunk to use WebAssembly and we'll get all the benefits there. And then, 6 months from now, we'll tackle the next chunk. And then over time, we end up opening ourselves up to bigger and bigger horizons for how we can do things. So I think microservice design pattern might have done us all a big favor as far as beginning the process of future-proofing us over the kind of 90s and early 2000s sort of monolithic, gigantic application server pattern that I and others used to use.
I remember actually first time we met, you were talking about like, hey, what if everything in my house could share compute, right? And be able to do that. And so is that eventually, I know we're looking out into the future, right? But is that something in the future where WebAssembly allows the Raspberry Pi plus the Nest thermostat, plus my smart TV to help me mine Bitcoin, while I'm doing it. I know maybe that's
I'm nodding along till you say Bitcoin, and then I'm like, oh, we went there, huh?
Maybe
answer ChatGPT questions. That's the future of computing, right?
No, maybe that's not the use case, but yeah, but no, like, I mean, is that truly the vision that we're working towards? Is that something that and I guess like time frame wise, I mean, is that still 10 years out, 20 years out, or is that, kind of crystal ball-y, like 2 years out? Curious about that.
That's our vision. I had originally kind of called it the 5-year vision. I thought we could get there in 5 years. Now, I think it's going to be less. I think it's going to be three years from now, maybe 2. Part of that is because the ecosystem around WebAssembly is growing in really interesting ways. I mean, we've gone from, in just a few short years, being very browser focused to now saying, there are all these different ways that we can apply it. But also, everybody's kind of chunking out the work. And we're getting observability from Dylibso. We're getting, cloud services, hopefully from Fermyon. We're getting UDF functions inside of databases from places like SingleStore. And we're starting to see all these different groups working toward this kind of same goal where we should be able to take the same binaries and do very interesting things with them, chunk them out, send them to the nearest piece of compute that's available for you, the nearest piece of trusted compute, however you want to kind of think about that. And I think we're well on our way towards sort of the next, if distributed computing is a staircase, right? We hit a couple of good stairs when we figured out how to do microservices, Kubernetes, containerized applications. I think we're going to leap about 5 or 6 stairs ahead in the next couple of years because of WebAssembly. I don't know that it's going to be the top of the staircase, but it's going to get us to a place where we're doing things that have never been done before, like being able to take the same compute workload and move it from a data center to the edge, to the far edge, to your IoT device, and, to your watch.
I totally agree. And just to add, a lot of times people say, well, what is WebAssembly? And they say, well, it's neither web nor assembly. But in this case, I actually think it's helpful to think of it as both, right? The evolution of the web, which originally was this, interconnected network of standardized compute in HTML, CSS, and JavaScript. Well, that was the assembler for the web. The assembler for WebAssembly is the Wasm instruction set and interconnected devices that share a common compute format. You have a web of assembly of compute that can all interop in really interesting ways. And I think Matt's right. I think we're accelerating the pace to get there because of the growth in the ecosystem, the advanced tooling, and the increasing set of places where you can run WebAssembly and actually build performant, reliable systems is growing every day, and that's super exciting.
Well, once my iRobot vacuum can help me answer the question of what's the best recipe for chicken parm when I ask ChatGPT, that's what I'm looking for here, guys. Like, that's the future that I want to see. So, I'm glad you guys are working on it. But one thing that we've talked about a bit, but I want to go into a little bit more, is WebAssembly been around since 2015, I believe. And so we're going on, that's 8 years since inception, right? And so obviously one of the ways that's going to spring forward is Dylibso and Fermyon, right? Like, it's what you guys are building on and making it easier to use. But I think there's a bunch of other stuff that's happening in the ecosystem with the Bytecode Alliance and with standardization and with, all these different things. And so I think I want to frame it up for people, really, why now? Like, why is WebAssembly going to be adopted now? What's happening out there in the world to enable that to occur? And so, Matt, maybe you start off with that.
You're giving me all the easy ones except the Kubernetes one. I think Ruby was around for about a decade before Rails hit. When Rails landed, completely changed the perspective of Ruby from a sort of niche, interesting, Shelley-like language to a core programming language that could be really, really productive for web developers and others. And I think that we saw that moment kind of crop up in WebAssembly in, 2019, 2020, where people started looking at it and saying, well, there are things we can do outside the browser. And we started to see Wasm Time, Whammer, a bunch of these external to the browser kinds of runtime environments. And I think that was kind of the Kickstarter for certainly Fermyon, and I imagine many other companies. That was kind of the Kickstarter where we went, okay, now we can build really groundbreaking things on top of this. Bytecode Alliance. So the virtue of WebAssembly and why it succeeded where applets and Silverlight and Flash and all the other previous in-browser runtime environments kind of stumbled is, in my mind, they started by putting it in W3 and saying, let's work together on a standard. The Mozilla team immediately reached out to Chrome and Safari and at the time IE teams and said, let's all participate in this together. We'll build something that we can all agree to support. And just because that was the foundation upon which it was built, and it was open source from the beginning, it was well specified from the beginning, that means that really for us now, we can really kind of accelerate development of it working collaboratively. And the cross-platform, cross-architecture, cross-product, cross-device kind of thing can still be just a thing that's a facet of the system. Because of that, then, I think when we see Bytecode Alliance get started, as we have seen, Bytecode Alliance get started and begin to host a lot of these next-gen projects, and we see, CNCF start to get involved and host Wasm Day and host some various WebAssembly projects. What's happening behind the scenes? The foundation that was built to enable that was that WebAssembly was done as a standard, and the people who were originally invested in it did an excellent job of articulating out loud, this is how it works, this is what we envision for it, that here are some runtimes that you can use for it. It took 5 years before I think that really got going. Compared to many other technologies, 5 years is not long. Now I think we're about to hit that big explosion where we go, okay, took us 5 years to build a foundation. Now what are all the things we can build on top of it?
Totally agree. Wasm time is one of the more popular runtimes for WebAssembly in the kind of the non-web embedding space. And it's out of the Bytecode Alliance. And it only hit 1.0 6 months ago. So before technology reaches 1.0, it is hard for large organizations who've invested, lots of resources in their stack to fully adopt technology. And now we've kind of agreed that, okay, this is the specification, this is how we're implementing it, this is how you can rely on, these APIs to persist over time. I think that was a big milestone, which we're already starting to see a lot of increased adoption. So, it's time to take it seriously. I think that lots of organizations are starting to see that. Then it's just a matter of can we get the tooling? Can we get the interest and organize, teams around identifying why it's a benefit to run WebAssembly? And I think that there's lots of companies that are doing a great job of doing that already. So I think it's an exciting time for WebAssembly. We're going to see it just blow up.
Your 1.0 milestone is a really good heuristic for gauging how much velocity is picked up, right? It took the specification quite a while to hit 1.0. Then along comes Wasm time. It took a while, but not as long as the specification. It took a few years. Spin is hitting 1.0 right now. And the reason why is because Wasm time hit 1.0 6 or 7 months ago. So the core of what we were building stabilized. We're just icing the cake at this point. And the reason why Wasm time took less time to get to that point than the earlier browser environments is because the specification had hit 1.0 and had matured on that. So we're definitely seeing that increase in velocity right now. And version numbers are an easy heuristic to look and say, oh yeah, I can see things are maturing much faster now. Developers are saying it's easier to get to a stable spot now than it was a year ago, which is easier in turn than it was 5 years ago.
Yeah. My last question on WebAssembly before we wrap things up is, Steve, I'll have you take this. What keeps you up at night? Before Matt, you answer. Steve, why don't you kick us off? What keeps you up at night about the WebAssembly ecosystem? And by the way, I'm continuing this trend apparently of asking you the harder question first. So congrats.
Contrary to how most people, I think, interpret that question about, the fear that keeps you up at night, for me, it's the adrenaline rush and excitement about how early can I wake up tomorrow to start working on that thing again. And there's just so much interesting stuff happening from gaming platforms to serverless to web applications and browser technology, database tools in WebAssembly that it doesn't matter from which angle you're coming into WebAssembly, there is something for you to explore and to sink your teeth into and to still innovate. It's still very early. So for me, it's like a call to action. How quickly can I get back to doing what I was doing? Because somebody else out there is going to have a better idea and implement it in a more smart way than I did and take that space. But for me, it's really more about the excitement that I have around the technology. It's I can't sleep. I got to get back to it, right?
Well done. And I'm going to give the, what keeps me awake at night wondering, for me, the number one risk that WebAssembly as a whole has to do with languages. The success of WebAssembly is entirely contingent upon gaining a lot of support from a lot of different languages, which involves a lot of very different communities with a lot of very different cultures and practices and histories. Each and every one agree we will implement the specification in its entirety. And we saw, some like Rust, just boom, out of the gate, done. Yep, check. Others like C and Ruby have moved along a little more slowly, but both of them are rapidly reaching stability. Then there are some like Java where I'm going, come on, please move faster. What can I do to I'll buy you donuts every day. Just move a little bit faster. And others like Objective-C is the last one that sort of stands out to me. Like, I Googled it. I can't find anybody talking about Objective-C in WebAssembly. And yet Objective-C is one of the most popular programming languages according to RedMonk's language rankings. And it seems like it should be fairly straightforward to do WebAssembly. But, we need to see a huge group of languages, really as many of the top 20 languages as we can, adopt WebAssembly. And if I wake up in cold sweats at night, it's like, oh, Java's not going to support WebAssembly, something like that. So that's the big one that keeps me.
Is there like a canonical list that tracks the language support across the WebAssembly ecosystem anywhere?
Thanks for giving me that opportunity to plug. The Fermyon uses RedMonk's language rankings, and we try and track the progress that each language is making. It's all open source. We've got it all in a repo in GitHub, but we've got it on the Fermyon.com landing page, or you can go to github.com/Fermyon/Wasm language guide and contribute if you know things that we don't. It's exciting to see languages like Dart and Kotlin, who are this year making huge leaps and bounds, but I am so outside of those ecosystems that it's a good example of a case where if you know something and you've played around with it, definitely we'd love to get a contribution on the guide for that kind of thing, because we really do want to track this absolutely essential piece of the WebAssembly ecosystem.
We'll put that in the show notes so that everyone can reference it. What will be very cool is when this gets released, actually, it will be after the, I believe, first WebAssembly only conference in the history of WebAssembly. So I think there'll be a lot of cool things that we link to too in the show notes, just based off of that from both companies and also just from the ecosystem as well. But, we now get to move to fun questions at the end. And so what I'll start with is, Matt, what's your favorite technology or app that you've played with recently?
Does this have to be a WebAssembly one or
no? It could be literally anything.
Okay, I'm going to go without a WebAssembly. So I'm a big fan of Remarkable Tablet. A Remarkable Tablet is sort of like an e-ink display, but I recently discovered, they've been adding all kinds of features, but I recently discovered that I can actually sort of like screencast from my tablet to my display and then be able to illustrate things by hand on the tablet, which feels like paper and pencil. And it's like, I'm so much a visual person that I just, so easy to use. So that's been the one that's been kind of my big go-to right now. I've had the tablet for years and I use it to bullet journal and stuff like that. And now it's like I've found a new toy in a toy that I already own. So I've really been enjoying that.
That's cool, because I wouldn't have thought, tablets have been around for a while, and that's a cool innovation to see.
Yeah.
Steve, what's your answer?
I'm a language nerd. I've been picking up Zig over the last several months. It's taken me the last several months just because I have no time. It's a very interesting language. I'm very bullish on their approach, how they're designing their compiler, and like the dev versus kind of production, compilation mode. I hope that the team continues doing some great work. Yeah, so Zig is probably the thing on the top of my list.
They had a big WebAssembly announcement recently where they reworked a bunch of stuff.
They have great WebAssembly support, but I think the announcement was about them using a WebAssembly compiled version of their compiler to bootstrap the compilation of the language itself, which reduced a bunch of friction for developers having to, track changes, to use the new changes of the language and recompile the compiler to support those changes before you can actually use those new features in the language, which is this just Russian doll effect of nesting compilers all the way down, and WebAssembly solved that problem for them. So it was a very unique use case of WebAssembly, I thought.
Yep.
Well, Steve, what's your favorite snack?
I guess I'd have to go with the peanut butter filled pretzels.
It's fair.
Oh,
Matt?
No, it's going to cause me to reconsider my favorite snack. Mine is probably technically dessert, but I love cannoli, and every once in a while we'll get like a bunch of mini and they're just so good. I'll eat them whenever. But also now I'm thinking peanut butter and pretzel things. I eat those a lot too. So
I love it. Well, thanks so much, guys, for being on the podcast. Steve, where can people find you? And then Matt, if you could go after that.
I go by Nilslice everywhere on the internet, Nilslice on Twitter and on GitHub in particular. I think those would be great places, to reach out. My DMs are open. Happy to nerd out about everything WebAssembly, and that's it.
And I am Technosophos everywhere, TECHNOSOPHOS. So likewise, Twitter, GitHub, those are probably the places where I'm most active and easiest to get a hold of.
Neither of you could have made it easier by just using your name, but it's all good. It's all good.
Do you know how many Matt Butchers there are in the world?
I guess that's true. But no, thanks so much for the time, guys. This was an amazing conversation, and looking forward to a lot of the news that you guys will be putting out, at Wasm.io and other conferences in the future.
Thanks, Shomik.
Thanks for having us. This was fun.